So to start our chapter about fire, we first want to think about, let's get our minds kind of centered on fire. Here's some fire over here. We can talk a little bit about how fire was thought about in the earlier days. And to do that, maybe I'll draw the Greek god Prometheus. There we go. It's just a quick drawing I did. And Greeks thought that Prometheus was a man who stole fire from the gods and was eternally punished. Kind of graphically, his innards would be chewed out by a bird as he was chained to the ground. Luckily, we know that's not really the case, and our chemical idea of fire changes. So, sorry, Prometheus, that all that work you did for fire, we don't actually need. Because the way we define fire, or really energy, because fire is a form of energy, we want to think about energy as the ability to cause change. Okay, energy is not matter, right? It doesn't take up any space. It's not made up of any atoms. It's just basically whenever there are atoms moving or changing structures or density, we have a transfer of energy. Okay, so fire is certainly an example. We also have things like light. Okay, and if we focus on these two for a second, fire or light, I mean, these are forms of heat. These are actually both parts of energy that are called exothermic reactions or processes. And exothermic process is anything that releases energy. So in a fire, which is a chemical reaction with usually some type of carbon chain and O2 that causes to create carbon dioxide in water, right? And fire is hot. I don't know if you knew that, but fire is hot. And in all exothermic reactions, this releases energy, but it also makes the products are hotter than the reactants. Oops, there we go. So fire is certainly hotter than the reactants, even though fire isn't actually matter, it's just our ability to observe a chemical change occurring. Because what we do see, so say we draw kind of like a combustion reaction, we have methane plus O2 gas, we apply some energy, and we get carbon dioxide and water, right? So this is very hot. This is cool. And so also in a fire, you'll notice that there's ash, smoke and ash. So basically ash and this charred kind of like smog or smut that you'll see on objects after a fire, those are reactions that did not react completely to the reaction. There's still some left over. Okay, but a big idea here is that changes in matter are basically accompanied. I have to think how to spell accompanied. Give me, like, there we go. Accompanied by changes in energy. So whenever we have a change in matter, we have a change in energy. That's the ability to cause change is energy. So we can't have things changing without energy being present. Okay. We'll talk a little bit more about exothermic and endothermic reactions in the video below.